Okay, today we are going to discuss about a behavior in 1D flow, which is a hysteresis behavior. Okay, so in order to explain this behavior, let's consider a system which is the following: x dot is equal to rx plus x cube minus x to the power of 5. Okay, so in this system we will observe the hysteresis behavior. Okay, let's see the behavior of the system by plotting the phase portrait. So this is the curve, and r is the control parameter, and for some r value we are having 3 fixed points, this and this. Okay, now if I change the r value, if I increase the r value, I don't think there will be any change in the number of fixed points. Let's decrease the r value. If I decrease the r value and take it to negative, okay, suddenly what I observe is, instead of 3 fixed points, I'm having 5 fixed points. Okay, now let me decrease it further. If I decrease it further, after some amount of r, I am having only 1 fixed point. Okay, so first let's identify what are those fixed points. So in order to identify, let's put x dot is equal to 0, which will give us the following: x star is equal to 0 and x star to the power of 4 minus x star square minus r is equal to 0. Okay, so to solve this, what I'm going to do is I'm going to introduce a new variable p, which is equal to x star square, so that I could rewrite this equation as p square minus p minus r is equal to 0. Okay, so now let me write a solution for the quadratic equation, which is p is equal to 1 plus or minus root 1 plus 4r by 2. Okay, so now once I solve this, then if I take a square root, I will get x star. Okay, but in order to have a reasonable x star, which means in order to have a x star as a real value, okay, my p value should be at first real, right? So p should be real, but is that enough? What if p value is negative? If p value is negative, there is no meaning for x star, right? So it should not just real, it should be positive. Okay, it should be a positive real value. Okay, what are the conditions in order to have a positive real value? So in order to have a positive, first let's see, in order to have a real value, okay, so this quantity, okay, should be positive. The whatever inside the square root, that has to be positive, otherwise this p will become a complex number. So in order to have that positive value, so 1 plus 4r has to be greater than 0. Okay, if that has to be greater than 0, what is the condition on r? R should be greater than minus 1 by 4. Okay, what if it's less than 1 by 4? If r is less than 1 by 4, sorry, minus 1 by 4, then no solutions. Otherwise I will have only one solution, which is x star equal to 0, so only one solution. Okay, fine, but in what range it will be positive? Okay, So it will be positive only if this quantity, square root of 1 plus 4r, if that quantity is less than 1, then p will have a positive value. Okay, otherwise p will have a negative value. So what is the condition in order to have a positive value? 1 plus 4r so 1 plus 4r has to be less than 1. Okay, it should be less than 1, only then I will have two roots where both roots are positive. Okay, if this has to be true, then what is the condition on r value? R has to be negative. Okay, so R has to be negative, only then the p value is positive. Okay, so if my r is in this range, minus 1 by 4, yeah, then I'll get two solutions for p, where both the solutions are positive. So this equation will provide me 4 solutions. Okay, in addition to this, I will get 5 solutions. Okay, so if my r value is greater than 0, then one of the root will be positive and another root will be negative. Okay, so for one of the root I will have 2 extra solutions, but for another root which is a negative, I will have no solutions. So in this range I will have 2 solutions from this equation and 1 solution from this equation, which will give me in total 3 solutions. Okay, so that's what we have observed over here as well, right? So let's see, let's see this condition first. If my r value is less than minus 1 by 4, which is 0.25, okay, exactly at 0.25, so 4 more solutions is getting emerged. Okay, so yeah, but below that there was only 1 solution. Okay, but when I increase the r value to 0 or above 0, let's see what's happening. Above 0, there's only 3 solutions, this one, and this one. Okay, right, so now we are able to identify what are those fixed points for a given r value, right? Now what are we going to do is we are going to draw a bifurcation diagram. So for bifurcation diagram for this equation, we need to plot r versus x star, which means we are going to plot this equation, right? This equation. So let's plot this. If I plot, so one is x star is always 0, another one is this one. Let me zoom out a little. Okay, so this is the bifurcation diagram. Okay, and we are getting it like this. Now in this bifurcation diagram, so if you see when r is very small number, okay, less than minus 0.25, we are having only 1 solution, and greater than 0 we are having 3 solutions, and in that small range we are having 5 solutions, right? Okay, so now in this bifurcation diagram, which are stable, which are unstable, I leave that to you to identify, but once you identify, you will get a bifurcation diagram in the following manner. Okay, so this is your bifurcation diagram, and in this bifurcation diagram, this RS value is our value which we have identified, minus 0.25, right? So where this branch and this branch are unstable and this branch is unstable, okay, where these three branches are stable. Okay, now in this, let's see how the system shows the hysteresis behavior. Let's say maybe I will explain it from this picture. Okay, let's say I have my R value which is very, very small, which is less than my RS value. Okay, if I'm having a value very, very small, then that's a stable fixed point. So most probably I will have my X value at this point, right? And when I keep on increasing my R value, what's going to happen? I'll still stay here. My X is still going to have 0 value, but once I reach my R value above 0, a little disturbance could either go this side or this side. Okay, maybe for illustration purpose, let me assume that it's going to go this side. Okay, if it goes this side, then suddenly there is a jump. Okay, so suddenly there is a jump in the fixed point, and then if I raise my X value, it's gonna trace this trajectory or this branch. Okay, now okay, let's say you want to take the system back to the state where X star is 0. Okay, what you have to do is you have to reverse the thing, right? You have to reduce the R value less than 0. But if you reduce the R value less than 0, what will happen is, say you are here and you are reducing the R value. At this point, if you further reduce, it will stay only here and it will not jump to this position at this state. Okay, and you will achieve this state only if you reduce further, and if you reduce below this RS value, only then there will be another jump, okay, which takes you to X is equal to 0. Okay, and this sort of behavior, okay, is known as hysteresis behavior. Okay, so in the next video we will see some physical examples. Thank you.